All right, this is section 4.7. This is the last section we're doing in chapter 4. Your test is going to be over sections 4.5, 4.6, 4.7, and 4.8. Remember, we did this chapter a little bit backwards. We did 4.8, and then we did 4.5, 4.6, and here's 4.7. Well, if you're looking at your textbook within section 4.7, I've even changed the order of it because I've found over the years that it works better to do it this way. Okay, so this is about the quadratic formula, which you have probably seen before. When it's in the form, your standard form of a quadratic, ax squared plus bx plus c equals 0, and a can't equal 0. Remember, the reason a can't be 0 is because if a was 0, my x squared term would go away, and it would then be a linear function. Okay? So now, the discriminant is the part of the quadratic formula that is probably new to most of you. Okay? The discriminant is just b squared minus 4ac. Now, what does that do for us? It tells us how many roots and the type of roots we have. Okay? So when b squared minus 4ac, when that value is bigger than 0, you are going to have 2 real roots. Okay? When this same value happens to be less than 0, you're going to have 2 imaginary roots. Okay, and what that means is you're going to have a negative number underneath the radical, and when you simplify it, there will be an I in it, in your answer. So now, what happens when your discriminant is equal to 0? You have 1 real root. However, we call that a double root. Okay, and you'll see why in just a few minutes. Okay. So now, here is your quadratic formula. And problem 1 says, using the quadratic formula, what are the solutions? Well, first, notice this is not in standard form. I've got to move this 4 back over here. So I'm going to subtract my 4 from both sides. And I get 2x squared minus x minus 4 equals 0. Now, before you plug into the quadratic formula and start working, I want you to find the discriminant. Okay, remember the discriminant is b squared minus 4ac. So my b value is -1. Square that. A is 2, c is -4. So -1 squared is 1. When I multiply -4 times 2, I get -8. Times -4 is a positive 32. So combine those, my discriminant is 33. So what that means is I'm going to have 2 real roots. Okay. So now look at your quadratic formula over here. When I start plugging things in there, I've got a negative b. Well, remember, b was -1, so I have a -1 plus or minus. Look what's under your radical, b squared minus 4ac. Well, guess what? I already did all that work over here, so I'm just going to write it over here, not doing it all over again. And then on the bottom is 2 times 2. So to finish simplifying, I'm going to end up with a +1 plus or minus the square root of 33 over 4. And I want you to remember that this is really 2 answers. Okay, you can leave it written like this, but here are the 2 answers that you really get. First answer, we're going to ignore the negative sign, and I'll have 1 plus the square root of 33 over 4. My other answer, I'm going to ignore the positive sign here, and I will have 1 minus the square root of 33 over 4. Those are your two answers. And something we've not stressed a lot in the other videos is what this tells us. Well, remember, your roots, the solutions, the zeros, they are your x-intercepts. So this is where the graph will touch my x-axis. It will touch it in two places. So now, problem B. All right, once again, I'm going to ask you to go ahead and find the discriminant first. So 6 squared minus 4 times 1 times 9. I get 36 minus 36 is 0. And remember, when your discriminant is equal to 0, you end up with one real root. Well, so let's see what that looks like. Over here in my quadratic formula, b is 6, so that's negative 6 plus or minus. Well, my discriminant, I already found it over here, so that is 0 over 2 times 1. So negative 6. The square root of 0 is 0. So if you take negative 6 and add 0 to it, you just get negative 6. If you take negative 6 and subtract 0, you get negative 6. Okay, for this problem, I'm going to go ahead and write it all out. If we have another one like this, I'll probably skip part of it. Okay. Now, this one does not have a radical left in it. So I'm going to split this apart into negative 6 plus 0 over 2 and negative 6 minus 0 over 2. So I get negative 6 over 2 gives me negative 3. Negative's kind of hard to see there. It's almost part of my equal sign. Let's try again. That's a little bit better. And then negative 6 minus 0 is negative 6 over 2. Also gives me negative 3. So I still got two answers, but they happen to be the exact same answer. That's why they say this is a double root. I really get one answer, but I get it twice. So how many times is this graph going to touch the x-axis? Just once. It's going to touch it at negative 3. So here's our definition for double root. You get the same answer twice. Okay, a double root only touches the x-axis once. Right, so here's one more, and this will wrap up chapter 4 for us. Okay, in class we're going to look at a few graphs, or how to sketch a few graphs based on the roots, but we'll do that in class together. All right, so for this problem, I'm going to start out with my discriminant. So b squared minus 4 times a times c gives me 4 minus 12 is negative 8. So remember, when your discriminant is less than 0, you're going to end up with two imaginary answers. So let's plug that into our quadratic formula and see what it looks like. Okay, so x equals negative b, well b is 2, plus or minus, your discriminant goes under here, and then over 2 times 1. So I've got negative 2 plus or minus. Now, when you are simplifying a square root with a negative under it, remember that can be rewritten. Actually, I'm going to put it out here to the side so I don't have work in the middle of what I'm trying to do. Okay, instead of the square root of negative 8, I'm going to split that apart into the square root of negative 1 times the square root of 8. Well, the square root of negative 1 is an I. The square root of 8 can be rewritten as 4 times 2. The square root of 4 gives me a 2. So I have 2i square root 2. So 2i square root of 2. And then on the bottom, I've got 2. Also in this problem, you see something that we did not get with the others. I want you to look at all of the things that are outside of the radical. All of those can be divided by 2, so you need to go ahead and do it. If you can only divide 2 of them by 2, don't do it. It's got to be all or nothing. So when I divide those highlighted terms by 2, I'm going to get negative 1 plus or minus I square root of 2, and then I'm going to have a 1 on the bottom. Okay, so since it has a 1 on the bottom, I don't have to write it there. So now, remember, I told you when your discriminant is negative, you have 2 imaginary roots. That's where you have to remember that this is 2 separate answers. You've got your negative 1 plus I square root of 2. You've also got negative 1 minus I square root of 2. And in all of the others, you know, my solution here has also been my x-intercept. Well, do you have any imaginary numbers on the x-axis? You don't. So this would happen to be a graph that never touches the x-axis. So let me show you real quick. I'm going to grab the graphing calculator and show you what it looks like. Let's clear this out. X squared plus 2x plus 3. So let's graph it, and you can see this parabola is completely and totally above the x-axis. No matter how far the left side and the right side extend, they will never touch the x-axis. That's what imaginary solutions look like. Alright, so that is it for section 4.7, and that wraps up chapter 4 for us. Make sure you let me know if you have questions.